Okay, so we're talking about the HEC-RAS. Standard step method is what HEC-RAS uses. It uses the energy equation to get my velocities and water depths. And WMS uses something called the cross-section database. And the cross-section database is just where your cross-sections are stored in WMS. It's just a bunch of text files that it's used to store the cross-sections. It's not a database necessarily, it's just some files, text files. So the way you set up a HEC-RAS model is you set up at least two kinds of coverages. You need a centerline coverage, a 1D hydraulic centerline coverage, and then a 1D hydraulic cross-section coverage. And the centerline coverage has your stream centerline and your bank arcs. Your cross-section coverage has your cross-section locations. And then it's, as an option, you can define something called an area property coverage. And your area property coverage has polygons that represent different Manning's roughness values. So maybe you have one polygon that represents a commercial area, another polygon that represents your river channel. Yeah, it's kind of like land use. So this is what a centerline coverage looks like. It's just your stream and your bank arcs. The purpose of setting up the centerline coverage is so WMS knows where your thaw weg for your stream is located. So that's the bottom of your stream. And also it knows where your bank arcs are located. And those points are important because they're exported to HEC-RAS when you export your model. Cross-section coverage, this is what a cross-section coverage looks like. It's just some lines that represent your cross-sections. And those lines should be perpendicular to the flow in your model. An area property coverage, like you mentioned, it's like a land use coverage that has different types of Manning's roughness values. And you can define different properties for different polygons and then define Manning's roughness for each of those properties. When I create cross-sections, there are some rules to follow. You should create cross-sections wherever you have changes in flow rate, changes in roughness, changes in conveyance. So if the river gets wider or narrower at different locations, you need a cross-section. Wherever there's a change in slope and over large distances, you should have cross-sections. So for instance, if I have changes in roughness values, I need a cross-section where there's a change in roughness. So these polygons represent different roughness areas. I need to add cross-sections wherever I have changes in roughness. Wherever I have a change in slope, it's a good idea to add a cross-section. Wherever I have a long, a meandering stream or something like that, you would want, well, okay, so WMS or HEC-RAS requires something called left and right overbank length, and WMS uses the bank arcs to compute the left and right overbank length. And so it's important to get those bank arcs in. If you don't have them, then WMS will not be able to compute the left and right overbank length. HEC-RAS also has something called an ineffective flow zone. That's where you have circular flow where there's no net flow in your stream. So that maybe if you have something like this where your stream is going out off to the side, you can define ineffective flow zone. After I've defined my cross-sections and my stream center line and my banks, I can select an option to convert my conceptual model, my cross-sections, my stream center lines to a schematic. And this is kind of like in SWIM. I do 1D, I do my coverages to schematic. It's the same thing in HEC-RAS. You convert your coverage data to a schematic. And that creates reaches and cross-section points in my hydraulic modeling module. Once I do that, I can run HEC-RAS. I just save my file, run HEC-RAS, and after I've exported my data to HEC-RAS, there are a few things that you need to do. You need to verify the geometry, so just look at make sure your cross sections are here. So here's the cross sections in HEC-RAS. Here's my stream center lines. WMS does not compute lengths across a junction, so if I have two streams that come together, I would need to go to this junction point and define my lengths wherever two streams come together. And there's an equation that HEC-RAS uses to whenever two streams come together, and so it's important to define those lengths at a junction point. And that's in this. And you can determine that length by using the measure tool in WMS, just this tool. Draw a line and get the length. You can also define, you also have to define your boundary conditions in HEC-RAS, and your boundary conditions are your flow rate, your flow values, and your upstream or downstream or both boundary conditions. You only have to define, if you're doing subcritical flow, you only have to define a downstream boundary condition. You don't have to define an upstream boundary condition. Most of the time you're just doing subcritical flow. You may have critical flow, and if you do, then you can define both boundary conditions.
In case of flash floods, I think it is supercritical flow most.
Okay. So in that case, you would do both the upstream and downstream boundary conditions. And for the boundary condition, you just define you can define normal depth, which just uses Manning's equation to get your depth at the upstream or downstream end. And it just uses a one-point Manning's equation. If you know what the depth is, though, you can also just enter the depth. So these are all the options for your boundary conditions. You can enter a water surface elevation, critical depth, normal depth, which is just your slope, or a rating curve boundary condition. So, okay. And then you can run HEC-RAS after you've defined all of that. After you've run HEC-RAS, you can go to, so don't make any changes to your cross-sections in HEC-RAS. If you make changes to your cross-section, then when you read your solution back into WMS, WMS will get confused. And so you go back, you run HEC-RAS, go back to WMS, read your solution, and when you read your solution, WMS creates something called a 2D scatter data set. So that's down here in the Project Explorer. It creates a scatter data set, and the scatter data set is a point at the intersection of each cross-section and each stream. So I have the point here, this yellow plus. It's kind of hard to see those pluses, but the yellow pluses here are my solution points. And HEC-RAS computes a water surface elevation at all those points. After I read my solution, I need, if I want to delineate my floodplain, it's a good idea to increase the number of water surface elevation points. And I can do that by using some tools in WMS that interpolate water surface elevation points. So there's a tool that creates additional water surface elevation points along my stream center line and also along my cross sections. And that'll just give me a better floodplain delineation when I go to delineate the floodplain. So there's my floodplain delineation, and we can do that. So I'm going to show you just a quick demonstration here. Okay.
This graph represents most of our work.
After solving the HMS, we generate here a hydrograph at the outlet. Then usually this area is full of buildings, roads, and all the important structures are usually after the outlet of the watershed. So in this case, the water spread like this and start to destroy or erosion in the soil. So could you guide us how we can use HECRAS to calculate the water depth and to choose which boundary condition? We know from this part here is the boundary condition we know, which is the hydrograph itself. And here is usually the sea or river Nile. In this location, if you open the satellite image, yes, all this region is very important. The economic area is here.
Okay.
So, which boundary conditions at the downstream? Yeah, for example, or
Okay.
you got my point.
So
It-
you
it
want
is
to
not a
know
stream.
you want to know how to do a HECRAS model
Yes.
between this location and
Exactly.
down here.
Look, this line it is not existent. We don't have stream that moves the water from the outlet of the watershed to the sea. No. Usually it is
So
not
what
there.
happens is it just branches out.
No, there is no branches. It is a flat area, and a lot of buildings are here distributed.
And the water just goes around the
It's a
building.
fan, you know.
Uh-huh.
This is how this is useful.
So HECRAS, it might not be the best model for something like that.
Really?
Yeah.
So which
How would you, because you'd have to have several streams, and for each of those streams you would have to define a cross section.
there is no clear stream.
Yeah,
You cannot
so
see streams. Just the
HECRAS is
overland.
it's a 1D model. It's
it's
not,
for rivers.
it's for rivers, it's for if you have a river. So for the river Nile, you could probably use HECRAS.
Okay, but most of our work is not for rivers. Here in this institute, we are working for the arid regions watersheds.
For the wadis. The wadis.
Wadis, yes.
So maybe HECRAS is not what you want to use.
Really? So which module in the tool in WS is the best for such?
Probably Geisha.
Also.
So set up a Geisha model for this area and you can get the depths. Get the overland flow. Yeah. Okay, so I
Do you think we have to do this workshop, or you just demonstrate and we skip with the people?
well I'll demonstrate, and why don't we just see what you think. If you want to do the workshop, you're welcome to do the workshop. Okay, so I'm going to demonstrate how to do a HECRAS model in WMS. Is that okay? And then we'll see how things go. Okay.
In the HMS, you show us something really intelligent, is that you explain the whole of application in 5 minutes. You show us how to build a HMS model in 5 minutes.
Yeah.
It was really amazing. Can you do something similar for HECRAS? So to be a very condensed movie that we can follow it later.
Yeah, I can do that.
It's great because this movie we will learn it from this many times later.
Okay. So So let me show you how to set up a HEC-RAS model. Here I have some elevation data, and this is actually a 10, so I have, these are XYZ points, I have triangles. I'm going to turn off my triangles, and these are the contours. And actually I have a river here, so here's a river. Let's read in a background map here. Well, I have a river that's at this location. It kind of comes down like this. Then I have a branch that comes down like this. So to set up a HEC-RAS model, I need a 1D centerline coverage. So I'm going to create a 1D hydraulic centerline coverage. And I just can create a stream. And in HEC-RAS, you create streams down upstream to downstream. So it's just the opposite of hydrologic modeling. So I start at the upstream end, go downstream. Then I'll create my little tributary stream over here. So that's my tributary coming in. I also need some bank arcs, and the bank arcs are where my stream banks are located. And so let's say my stream bank comes around like this. I'm following the contours. It's not going to be very accurate, but let's say this is my stream bank locations. So I'll draw that in. I'll also draw in this side, this left and right banks. And left and right, when we refer to left and right in hydraulic modeling, we're assuming that you're looking downstream. So you're up here at the upstream end, you're looking this downstream direction. But it doesn't matter what direction you do these bank arcs. Just going to draw them in. So I draw in my center line, my bank arcs. For my center line arcs, I assign those as center lines. We're going to define a river name for each center line. So I'm going to call this river branch. This is just a branch coming off the main tributary. And we'll call this branch for my reach. So I have a river and a reach. A river is my I can have several reaches for each river. In this case, I have this river coming into another river over here, and this river only has one branch. So I'm going to call that branch. This river, assign that one as a center line, and I'll call this river, we'll just call it main, and we'll call the reach upper. So this will be the upper reach in the main river. And then this river down here, we'll assign that as a center line arc. And this is in the main river, and we'll call this the lower reach. Then I assign these banks. I'll select all of these bank arcs and go to the attributes, and we'll assign those as bank arcs. Just assign them to be banks. Then I need a cross-section coverage. So my cross-section coverage, I just create that. Create a cross-section coverage. Select this Create Arc tool and just create some draw some cross sections. And the cross section should be perpendicular to the flow. So I draw those in for my tributary. I draw some cross sections in for my main stream.
This cross-section is supposed to be perpendicular to the line.
Yeah, the cross section should be perpendicular to the flow in your watershed. It should be perpendicular to this stream line, stream center line.
Also, like that, the cross section should be drawn from left to the right with the direction from downstream to upstream, isn't it?
It doesn't matter. So WMS, for WMS, it doesn't matter what direction you draw the cross sections in. If you're doing it in HEC-RAS, then yeah, you want to draw them a certain direction. But if you're doing it in WMS and then exporting it, WMS is going to figure out the direction to draw it, to save your cross sections when you do that.
You intentionally draw the cross section through a straight line.
Yeah, so I'm just doing it perpendicular to the direction of flow. So you may not have just a single line. You can have a line that changes directions. I mean, your flow in your floodplain might not be just straight down, straight across. I'm just trying to do it perpendicular to the contours. And that's what I usually try to do, is just do my cross sections perpendicular to the contours. So there's my cross sections. If I want, I can also create an area property coverage. And in area property coverage, you define your different land use types, or maybe if I have land use for this area, a land use shapefile, I can read that in. But let's say, so for this area, I'm going to start out by drawing a big polygon around all of my cross sections. And then I have one area here that's my kind of my stream channel, my main channel. I'm just going to draw a polygon representing that main channel. Or just, this is representing a stream. And then maybe over here I have a section of this town that's an industrial area or commercial area. And then maybe up here I have some residential areas, and then over here I might have forest. So I'm going to just build my polygons in this coverage. Then we go to edit materials, and we'll create some material types. Okay, so I have one material that's maybe a river, another that is my maybe my commercial area, another that is a residential, another that's maybe agricultural, and another area that is forest. Okay? And I can define different colors if I want. Maybe forest is green, agriculture is this color, residential we'll do orange, commercial and river will do blue. Okay. Then I go in, and for each of these polygons I assign one of those materials. So this is my river. This is maybe a forest. This is agriculture. This is residential. And then this is commercial. And I can make sure that I have defined materials for each of my polygons. If I go to my display options, turn on color fill polygons, and then I can make these transparent. And you can see that I've defined a material type for each of those polygons. So I'm going to turn that off for now. One thing I need to do to do a HEC-RAS model, I need to get my cross section somehow. I have this tin that has my elevation data, and to get my cross sections from that tin, I can select my cross section coverage. Then there's a River Tools menu, and there is a extract cross sections command. When I select this command, it comes up with this window that has several options. One of the options is to generate point properties. Point properties are your left and right overbank locations as well as your thaw weg locations. And I'm going to use my 1D center line coverage to get the thaw weg and the left and right bank locations. Also, I want to generate line properties, and that's my Manning's roughness values for each of my cross sections. I'm going to generate my Manning's roughness values using the area property coverage. I hit OK, and WMS will ask me for a file name. So this file name that I'm prompted for. This is the cross-section database. Let's just save this. We'll call this demo. That'll be my cross-section database. And so when I did that, WMS created these files. These are just text files that have the information for my cross sections in them. The other thing I need to do is go here to my centerline coverage, and if I select River Tools, there's this Map to Schematic command. When I select Map to Schematic, WMS will create a hydraulic schematic. And so I have these cross sections are represented by circles, reaches are represented by these orange diamonds. And if I go to my hydraulic modeling module, I can just look at the values for each of these cross sections. So here's this cross section, and I've cut all these cross sections. If I want to, I can go in and look at the attributes for these cross sections. These are the material properties that were assigned. These are the point properties. So this is my thaw weg, and I can move this around if it's not quite right. And then there are different options to edit this cross-section database. Also, I have these reaches, and these reaches also have attributes. The other thing I need to do is for the different material types that I've defined, the different polygons, I need to define a Manning's roughness value. So I go to the HEC-RAS menu, select materials. Those are my materials. If I go to material properties, I can define a Manning's roughness value for each of these material types. So agriculture, let's say the Manning's roughness is 0.05. Commercial, let's say it's 0.04. Forest, do 0.045. Residential, we'll do the same, 0.045. River, let's say 0.035. Okay, so those are my Manning's roughness values. Define all those. I also need to go to the model control, and I need to say that I'm using the materials for my Manning's roughness. So you set that. Then I can export this to select this export GIS file, and WMS will save a HEC-RAS GIS file out and start up HEC-RAS. So we'll save this out, and then HEC-RAS starts up.
Chris, if you already have a land use map and sort type, is it automatically detect the frame number, or you still will have to insert them? Sorry, Manning coefficient.
Does it already have the Manning's coefficients? Yeah, you would have, if you have a land use, then you would have to define the Manning's coefficients.
And we still have to.
Yeah.
I mean that it doesn't detect.
It would probably have the land use names, the names for the different land use areas, but it would not have the Manning's coefficients. You'd have to define those. And the other thing is you'd usually want a different Manning's value for your stream. And a lot of times a land use file might not have the stream in the land use file. And so you'd have to define your stream and define the manganese roughness for that. Okay, so WMS starts up HEC-RAS. Here's HEC-RAS. In HEC-RAS, I can look at my geometric data, and so here's those cross sections in HEC-RAS. And for these cross sections, I can view the cross sections, make sure they're defined correctly. There's my bank stations and my thalweg. One of the things I need to define is for this junction, this is my junction, I need to define some lengths for the energy equation at this junction. And so to get these lengths, I can go back here to WMS and I can use the measure tool to measure the length between this location and the downstream cross section. So the length is shown down here at the bottom of the screen, 1463 meters. So for that, for this length, I'm going to enter 1463. And then if I want to go, actually, that's this other one, 1463. And then for this branch, I measure from here, and then the water comes across here and comes down here. And the length there is 1284. So for the branch, it's 1284. So I just measure those, enter those numbers. We'll save this out. This is for the junction. And I need to, HEC-RAS needs the junction lengths. Yeah, just follow the center line at the junction. From one cross section, from the cross section before the junction to the cross section after the junction.
Is that because they are connected at not at the north? So they are intersected at the
Well,
north?
no, you can't define a cross section at a junction.
Because they are connected here. They are connected here, the center line, or
Uh-huh.
here. Because you have a layer I can see.
So, well, these streams are connected right here at this location. So this, I have this stream that comes down here, and then this other stream that comes into this stream, and they're connected at this point right here. That's the junction point, and I have to define the length from this cross section to this cross section along these streams. So like that, that's one length. And I have to define the length from this cross section to this cross section along this stream. And WMS does not export those lengths. It could, but we just don't export it, so you have to do it in HEC-RAS. Okay? Does that answer your question, or are you still confused?
Actually, yes, I still don't understand because I don't know. This line is the cross section, the center line. This is along the center line for this branch. Is this the center line?
This line right here, is this line the center line? Yes, this line is the stream center line. It's where the thalweg is located in the stream. And so you just follow the center line.
Okay, I understand. Now this is for the cross section. The cross section.
These are these blue circles are cross sections.
So we put the distance from the cross section on each branch until the cross section on the main.
Yeah. Wherever I have a junction, I need to measure that distance and enter it into HEC-RAS. Okay, then I need to enter my flow rates. And you can compute your flow rates do a hydrologic model, compute your flow rates. For my branch, let's say the flow rate is 500, or actually this is cubic meter per second. Let's say it's 10 cubic meters per second. Let's say my upper flow rate is 20 cubic meters per second, and then the combined flow rate is 30 meters per second. Then I need to define my boundary conditions, and I can define my downstream or upstream boundary conditions. For supercritical flow, I only need to define my downstream boundary conditions, so I'm going to do and I can measure the slope in WMS. If I go to this cross section, use the measure tool, and just measure across this cross section, WMS will give me my slope down here. So 0.0015 is my slope. I can enter that as a downstream boundary condition. Enter that for my boundary condition, and it'll just use Manning's equation with that slope at that cross section. I'll save that data out. Then I can run my simulation, and we'll call this demo, whatever. We're going to run supercritical flow. If I think there's going to be or subcritical. If I think there's going to be supercritical flow, I'd want to do a mixed simulation, or just supercritical. You could just do that. But I'm going to do subcritical. We'll do a computation. I get a couple of errors, and I can fix. Sometimes you'll get errors. You can fix these errors. So it says I have duplicate point data at this cross section 3553. So I'll go to my geometric data, go to 3553, we'll edit that, and at point 12, which is down here, I have a duplicate point. HECRAS doesn't like duplicate points, so I can delete that, and we'll save that out. And then the other duplicate point is on cross section 1060. So I'll go to this cross section at point 67 and 68. So I'll delete one of these, apply that. Delete that row. Save my geometry, and we'll try running this simulation again. So I'll compute. WMS or HECRAS finishes running. I can close this, and then I can go to my geometric data, and I can look at a profile plot. So this is what the plot looks like. And you can select, there are different options for viewing your profile in HECRAS. The other thing you could do is, if I want to delineate the floodplain for this model, I can go back here to WMS, read my HECRAS solution. So go to HECRAS, read solution. WMS creates this 2D scattered data, and this is the water surface elevation at each of these cross sections. So here my water surface elevation is this value. This is my water surface elevation. These are all my water surface elevations. Then I can create additional water surface elevation points. So I go to the centerline coverage and select this interpolate water surface elevations. And I'll create a water surface elevation point every, let's say every 60 meters. And you can select this option if you want to add additional, extrapolate your water surface elevation points. So what that does is it creates points all along this stream. So you can, it's hard to see, but they're displayed in yellow here. I have water surface elevation points all along my stream center lines. I also, it's a good idea to do the same thing with your cross sections. So you create additional water surface elevations along your cross sections. So now my cross sections have solution points. The reason I do this is so I can get a better floodplain delineation. So let's go back to my tin. And in the terrain data module, there's a flood menu. If I select delineate, WMS will use my tin elevations and my water surface elevations that are under this 2D scattered data to compute a floodplain boundary. And we'll talk about this later, but let's enter a search radius of 1,000. And I'm going to call this output to data set. We'll call it flood. Hit OK. And WMS computes some flood depths. So this is what it gives me. It looks like I get some flooding. It also computes water levels and flood depths. So there are two data sets, water level data set and a flood depth data set. And if I want to view these flood depths a little bit better, I can change some of the contour options. So I can do color fill contours and turn off these low elevations. You'll be able to see where the flooding happens. And if you want, let me just set some display parameters here. My projection. This particular area is in a place called, it's in South Carolina in the United States. So I'm going to use the South Carolina coordinate system. I need to set all these. I didn't have that set originally. So maybe I shouldn't have tried playing around with that, but anyway, I was just trying to bring in a background map and I messed everything up. So anyway, you can view, yeah, change the projection at the very beginning. Set your projection, and then you won't get everything messed up. But yeah, no idea.
When you flood plane, distance.
Yeah. So here's the floodplain.
This value for 1,000. This value is for the area.
Yeah. We'll talk about that later. So the 1,000 that I entered when I did the floodplain, that is for, that's a search radius. So each point on your tin, WMS looks at each point and tries to find the water surface elevation points that are closest to to each point on your tin, each vertex. And if a water surface elevation point is, if the water surface elevation points are above that ground, then there's flooding. And the 1,000 feet, 1,000 meters, whatever, was, that tells me that WMS will only search within a radius of 1,000 meters from each point on your tin, each elevation point on your tin.
1,000 distance from the processor.
It's the distance from each elevation point that WMS searches on your tin. So
Sometimes when I get this plane, I found very far from the main stream or main channel, I found water. And flooding area.
you get flooding.
It's very far from the.
Yeah, so there's no way for water to get there. So
Yeah.
you could try
That is
decreasing
why
your
I
search
asked.
radius. If you decrease your search radius, you might not have that happen.
Yes. I try many. I remember that I changed this value until I get the good result. Because all the time I found the water in some places there is no water there.
Yeah.
That's why I asked about this. Do you think if I use the 2G, it will solve this problem?
If you use Geisha or 2D HEC-RAS,
Yeah.
maybe not, because it's just a matter of delineating the floodplain.
So the main parameter which will affect the result is this radius distance.
Yeah, just the radius. So just change your radius. You can also, there's something called a quadrants, and we'll talk about that when we talk about floodplain delineation. There's a variable called there's quadrants, so it divides for each point on your elevation data set. It'll divide that point up into fourths, so it creates an axis and it looks at each quadrant. And WMS will take 3 points from each of those quadrants, or however many you specify. The default is 3. Like if I go to the flood menu, delineate, quadrants, I had quadrants turned on, so it'll look at for 3 points in each of those 4 quadrants.
So I increase this number.
You could, if you increase it, you're going to get more water surface elevations that could be further away. And so you might not want that. You might want to decrease the number or decrease the radius.
So I hope I have to decrease the radius and increase this number.
Yeah.
Also.
Maybe. Well, no, you could probably just decrease the radius, and you don't have to change the quadrants. But that's just another parameter for floodplain delineation, and we'll look at it in the slides. I'll show you what it means
Yeah.
in the slides. Any questions about HEC-RAS? Got it?
We have
All right.
to use the 10. We cannot use them.
Yeah.
So we
For
need to
HEC-RAS,
survey or
you can use a DEM to do a HEC-RAS model. You just cannot use a DEM to do floodplain delineation.
So we need the survey.
But you can convert. So if I have a DEM, if I have a tin, I can convert the tin to a DEM.
No, I know, but I'm talking about the resolution. The resolution of the them or 10. Because the
Yeah, so
cross
10s are
section,
usually
if
better.
you have a channel width like 100 meters, with the DM, it will 90 meters. So it will be
You probably need some survey data for your channel or something.
You said there is not good for floodplain delineation. Why?
Well, WMS cannot use a DEM for floodplain delineation.
Relative.
No. You could probably use one for floodplain delineation, but we don't have the capability in WMS to use it.
No, it's not the